I'm not going to go through it. I'm going to just start going through it up here. So you guys keep going.
I'm in the bottom right now. Then combine all of them. Five squares. Well, I don't have enough room right there. Am I allowed to try on the desk?
Yeah.
Well, how do you find that? Wait, what you did? X, you put 5x squared plus x minus 6.
What? She does?
I got the top, but then did you just multiply this out? Do we have to multiply these together?
I don't know.
There's not your bottom line. After the P and Q. Yeah.
You guys were too big.
They're like applications to do though. Plus minus 1 is 2.
Motherfucker.
You have to plug in all those.
No, why would you do that? Because those are the factors. And why would you? This is all the combined factor out.
Yeah. Because the Q was literally.
Yeah.
Did you get the same point as me?
Yeah. Yeah. Okay, but I'm talking about for the top, not the bottom.
Okay, but the top.
Solve for x. So you're right. The only way I can see to do it is P and Q. There's no rational roots for this one.
Really?
Like, so I graphed it, you know?
Yep.
Then I looked at where it crossed the x-axis so I could kind of have a cheat mode, you know what I mean? To see where it looks like it was crossing out a whole number plays. And then I just did second trace and found the zeros. And one of the zeros was x is equal to there's 3 solutions, right? So 0.925422292, one of our solutions. But we should be doing P over Q if we can, but none of these are rational. Second trace, 0, left bound. The one on your final exam will most likely just be, it'll be like pretty answers. Does that make sense at this point? It'll come out x is equal to 2, 3, and 1. Does that make sense? Yeah. I must have not wrote down the problem right.
What do you mean by final exam?
Question. Just a reminder, when you're solving a rational, once you get a common denominator, even over here, we got a common denominator, but when we multiplied it to 0, it was just gone, you know? But once you have a common denominator when you're solving, you can now ignore the denominator and just solve using the numerator. Because once you get a common denominator and you solve it, your denominator will be the same, right?
Yeah.
If you get x equals 1, if you plug in 1, our denominators are the same, so it's not gonna, does that make sense? Good question. Okay. Okay, I'm going to talk to you about, okay, so that one wasn't the best example, but were you on the right track? If you were able to get up to here, then you're probably good. Because then on an exam, they're going to come out exact solutions. It's going to be solvable by factoring or P over Q. Okay, so final exam review problem. So then these will build up and we'll hand this in at the end of the year, or like when I'm ready for you to hand it in, and you're going to get a good sum of points for it, just for doing these. So at the beginning of each class, we'll do some final exam review problems throughout from the year, and then that will really prepare you, and then once again, we'll hand this in for an assignment. So if you miss a day, you will have to go back and watch the video and have these all. Yeah. When? Yes, it's May, the first week of May, so it's coming up soon. We only have a month. But we'll be prepared, because we're going to do this every time. So you're going to title it, today is, these will be, what's the date? So you're you go like this. 3-17, and then problem number 1 on 3-17. So what I want you to do is expand. This is a problem I've seen. Expand the polynomial. So remember how we learned about, you could do this the long way or the quick way. Pascal's triangle, remember that? Pascal's triangle, or you could do it the long way, multiply these out and distribute this out. So, which way would you do it if you were going to tackle it?
I would do X squared minus 1 4 times.
You would go like this?
What are we naming this one?
This one, since it's to the 4th power, might not be too, it's called final exam review problems, and you're just going to do this always in the same section of your notebook. We're not going to have them in every time, but at the end. Well, that's why we're reviewing, but this one wouldn't be bad to do like this. But don't you have to be smart about doing this? Everybody paying attention. Wouldn't you need to distribute these two together, distribute these two together, and then distribute it all together?
Yeah.
So go ahead and finish that one off. Go for it. Go, go, go.
Actually, 3 on there.
There's one somewhere in my car, and you have my car, like, sit down, and then I begged it.
You know, there's a good time. Take her time to drive with that every morning.
I am doing on the too. Oh yeah, what am I doing?
That's the name of the or video.
You notice when you watch the video, sometimes you just gestures of the board without it.
Yeah.
You know?
This one?
I think the big one that is that right here, is Rob was supposed to look at.
My dad watched it today.
Right here, and like all the work.
You're just testing yourself out right now to see if you can get it right. If you can't, then you've got to figure it out.
Come on, let's work. Add all of them to get 1, 2, 4, 2, 4, got it.
I could have made a mistake. So if I'm wrong,
Okay,
we can fix it. You got it to do without Pascal's triangle. Next problem, ready for it?
No.
Oh. Okay, go for it. Problem number 2. So on your notes, you're going to write problem number 2. Okay, it says, this is, you're going to want to use Pascal's triangle. It says, what is the third term in expansion of 2x plus 1 to the 5th? So I will remind you of what Pascal's triangle, how to set it up. We remember that it starts out as 1. It's a triangle. 1s go down here, right?
Yeah.
Then 1, you add straight above, so that'll be 2, 1. 1, 3, 2 plus 1 is 3, 1. Now this is degree 0, degree 1, degree 2, 3. So we need to keep going to 5. 1, 4, 6, 4, 1. That's degree 4. We need to go one more. 1, 5, 10, 10.
1.
Okay, so this is degree 5. So then the third term of expansion, all we're going to need is the 10, correct? Now we're going to go, now I'll let you see if you can remember how to do it.
Yeah, that was almost what happened. Okay.
Well. Oh, it depends on how.
I was paying something but I believe I think that starts tomorrow and it's just coming around to
Who did that?
I think kids would go through walking jackets tomorrow and like kind of jacket and I have no idea how to do it.
So you stopped. Okay, so do we need to just go through it because everybody's forgot?
No.
So you take the first term, 2x, It counts down. 5, 4, 3.
Oh,
So 2x to the third. The back term will count up. 0, 1, 2. Unless I have that backwards, but I think that's right. Yeah. So now I can move down. So why didn't I keep going? Because I'm only meeting this term. So I know it's going to be that. So now just simplify. You have a 10 times a 2 and an x to the third times 1 squared. So now simplify it. That's 10 times 2 to the third, x to the third, right? 2 to the third, x to the third, times 1. So that would be 10 times 8 times x cubed times 1. So your answer would be 80x cubed times 1. 80x cubed. A lot of you missed that on the test. That was forever ago. But hopefully, did that make sense? Was it a good reminder? Now will we be able to remember it in a month? You've got to. You've got to. So these are problems you'll refer back to before you go take this. This is a problem I actually have seen very similar. It's just the front term. The front term counts up, and then for the degree, and then the back term. So it doesn't necessarily have to be x, but the front term's degree will start the highest to lowest, just because it comes first, and then the back term will be the 0 up to degree 5. Yeah, which they do. Look, 3, 4, 5. Like these just have to have to be 5 right here. Does that make sense? Okay, awesome. Next one, problem number 3. It says simplify. This one you should be able to do. Push yourselves, guys. Remember these things. Go for it. Go for it. Changing the instructions to divide. Okay. You guys go for it. I'm going to go for it for the video. It doesn't factor. That's why we changed the instructions to just divide.
What'd you do?
Don't look at mine. Do it by yourself. Now, once again, a reminder about this one is if this is a 1 in front, that's the only time we're going to use synthetic division. You set it equal to 0, subtract 2, so we're going to be using -2. And then you put in your coefficients, watching out, because you have to have all the coefficients listed, just a reminder. So notice there's an x cubed coefficient, x squared, x, and a constant. But if we were missing x, we would need to have had a 0 there. Just a reminder. So because our remainder was 14, this was not a factor, which makes sense. I mean, we already decided that, like the top didn't factor, you know what I mean? So.
Yeah, I did like 4 times of those.
Okay, simplify. Simplify. Now, what's not simplified? We have 2 fractions. Simplifying it would be putting it into 1 fraction.
So first I'm just maybe the bottom. Okay.
Yes, because simplifying doesn't, the denominator doesn't go away. It's only, the only reason we can do that with solving is because when we solve it, we'll be the same, you know? No, you can leave it, because why would we leave it factored? Because in the end, aren't we going to have to see if our top factors to divide out with the bottom? Does that make sense? You'd leave it factored and then that's fine.
Yes. Why no? -6. -6, but yeah, but I don't know. Still your friend on that. Oh, you thought.
that all the time.
Right, guys, we would get a common denominator, combine like terms, then we would say, okay, now that it has a common denominator, we can write it over one fraction. Then we would say, okay, now can we simplify that? Well, you only can divide out exact factors, so we would factor the top, which doesn't factor. So that means that nothing divides out, right? Because you can only divide out exact factors. And if the top doesn't factor, then there's not going to be anything that divides out. Yes?
How can say you have x equals x plus x squared and you don't have to go x cubed?
What do you mean?
And you find the right term and x cubed.
It was x cubed here too.
No, I mean on the denominator.
Oh, it should be x squared.
Okay.
Sorry. Now understand, if the top did factor, then you would factor it and see if anything divided out. But you've got to do that all after you've combined like terms. Because what happens is people will be here and they'll factor, hey, listen, because when one of you are the ones that don't get the 4, everyone's going to be upset. So what people do is, remember, they'll go here and then they'll say, oh, well, 6 factors. But no, that's not what you do, right? You have to combine like terms before you try to factor and divide anything out. Okay, I know, I'm just making sure. But I was telling you what to not do. That's why I was getting mad. Okay, find the solutions. You're making this harder than it needs to be. If it says find the solutions, it's where the graphs cross each other. If there's 2 graphs. You guys understand that?
Yeah.
Like if I say to you, solve x squared plus 2x, when does that equal x squared plus 1? You graph them and see where they intersect. So if you have 2 quadratics, see where they intersect. So x is equal to negative a half, isn't it? Crossing it, x is equal to negative a half. Yeah, I know, but we're doing our best guess. And x is equal to 1.5. You guys see that? So this is my solution, and this is my solution. If it said write it as an xy point, which actually this one, I'm pretty sure it said drag a star to where the solutions are. So this is what you asked was what people do on accident. They go, oh, there's my solutions, which is wrong. Does that make sense? So it's, yeah, those are the zeros, which a solution of just 1 quadratic would be the zeros, but of 2, it's where they intersect. Okay. Okay, awesome. Let's start today's lesson, 9-2, polar coordinates. So go to a different place to take notes because you're going to have that one designated area in your notebook to always take notes on for the review problem. Okay, so polar coordinates, we're going to go from, so far what we've been graphing is XY points in our time, you know, and those are considered rectangular coordinates. You go some distance for X and you walk right. If you were a person walking, if I said you go to this point right here, you would walk 3 units this way and 4 units up, correct? Okay, so that's one way to get there. That would be the rectangular coordinates, and that's how you would get to that point if you were walking. Now, couldn't we, if you think about it, so that would be fine, but couldn't we walk straight here?
Yeah.
So if we were a person standing here, we could walk straight here. So think about it. Wouldn't that be, if I said to you, though, to get to that point, if you were blindfolded and starting here, and I said to you, turn, you got to turn some theta, correct? You got to turn some theta and then walk that many distance, that much up. Does that make sense, everybody? So, rectangular coordinates would be 3 this way, 4 this way, which creates a right triangle. So like Dylan said, then this would be 5 units. Now, but if I say walk 5 units, they're just going to walk 5 units straight out. So that's why I'm going to say we'll go turn this theta direction clockwise and then walk 5 units up. And you'll arrive at the same point. Does everybody understand? So that's what a polar coordinate is. Instead of saying it as an x, y, it says it as a r theta. Does everybody understand? Going some distance out r, and then in a direction theta, which is counterclockwise from this axis here, which is actually called the polar axis. Also, interesting enough, this is what's going to be backwards. You know how we always usually it's okay to graph yx, but don't we always graph xy? Our theta, it is important that we graph theta first. So we would say, for example, this is going to be, you're going to go this many units, so like pi force units, and then walk out 5. You always say this, you always draw this first, and then walk out 5. Does that make sense, everybody? Yeah. So now, and then we'll talk about it in a minute, but I'm not going to get there yet. Okay. So now let's talk about it in general. So let's say that it's not exactly the point 3, 4, let's make it general because we're going to use these formulas. If we go out some distance for x and up some distance for y, that arrives us at a point. That would be our rectangular points to get to x, y. But let's write a general equation for r theta. So we're going to list down some formulas. So think about it, guys. If we were at theta, can't we go opposite? No. Opposite and adjacent. Oh, I see what you're saying. Yeah, tangent. So don't we know that tangent of theta equals y over x? Okay, write that down. We're going to be using that in a second. Then also, what else do we know? Well, from theta, opposite and hypotenuse is sine. So let's write that. So we would say sine of theta equals y, right? Y over r. Does everybody understand? So now let's have it in y equals form. So let's multiply both sides by r. So we're also going to be using y is equal to r times sine of theta. Now we also could say from theta we have our adjacent and hypotenuse, which is cosine. So cosine of theta equals x over r. Now let's get it into x equals, so we'll multiply both sides by r. So another thing we're going to be using is x is equal to r cosine of theta. And now, also, don't we know the equation of a circle is x squared plus y squared equals our radius squared? Isn't that true for a circle, guys? Yeah. So, and that's just Pythagorean theorem. X squared plus y squared equals this distance squared. So then that creates our circle here. So we're also going to be using that. X squared plus y squared equals r squared. And these are the formulas that we're going to be using to convert back and forth between polar and rectangular. We've got them all listed there. So I'm just going to briefly read it. So polar coordinates, to form a polar coordinates in the plane, find a point O, so that's just like the origin. And we call this, instead of the x-axis, the polar axis now, if we're going to do polar coordinates. So then we go up some directed angle and then out some units to P. So, I mean, we've already gone over that. This is making it much more complicated than it needs to be. Does everybody understand what we just talked about? That this is saying the same thing, but in more, it just makes it extra complicated. It says it the exact same way. If you want to read through this, you can. If not, or if we understand it, we're good. We good? Yeah, this might confuse you. So let's just do it. Let's graph this. Here we go. So we're going to graph. This is a polar coordinate. Notice 2, pi thirds. What's important is you graph this backwards. You don't graph this first. You don't graph 2 first. You graph. Yeah. So let's go up pi thirds. So from here, we're going up pi thirds right here, right? Like you said, it's 60 degrees roughly. So we're going up pi thirds. And now we're going out a distance of 2. 2 is our radius. So I'm going to just draw in a circle. I'll call this tick mark 1. Go out 2. So tick mark 2. So that point is going to be where they intersect, right there. That's going up pi thirds and then out 2 units. Yes. Yep. And you're going to see why this makes sense when I start converting back and forth. If we converted this, it's going to be an x point right here and a y point right there. So it'd be a little bit less than 1 and a little bit, and then up. Yeah, because that's just where we're going. So notice, instead of drawing in a right triangle, which we could have as well, that would be drawing some x and y point. It's just drawing it in polar coordinates instead. Same thing, different ways of getting there. Does everybody understand? Okay, let's graph this one. Here we go. You always graph theta first. So we're going down negative pi 6. So that's going down about this much. That's negative 30 degrees, just keep in mind. So, and then also it might be useful in a minute to have a unit circle just so you know, so you can be locating that when you get a chance. So we have negative pi over 6. And then we're going out 3 units. So 1, 2, 3. We could picture our circles here, right? You can just draw that one, but I'm just showing you what it's looking like. You know what I mean? Like, that's where we're at. So that would be the way you draw your polar coordinates. Now, once again, that is a rectangular coordinate. If we were to draw in a right triangle, it's going to be this x and y value here. And it will arrive at the same spot. It's just looking at it differently. Okay, cool. So 11 pi 6 and 3. So where's 11 pi 6? Almost to 12 pi 6, which is 2 pi, right? Yep, it is, right? It's the exact same, because 11 pi 6 is the same thing as negative pi 6. So we don't even need to redraw it. We'll say same. So, all good. No questions? Cool. Okay, so now we're going to be converting back and forth, and we're going to use those general formulas to convert from x, y coordinates to r theta coordinates, or to go from r theta coordinates to x, y coordinates. We can use these formulas. What time is it? Because the bell's going to ring in 5 minutes. Okay, this is a perfect one to do, and then we'll go to lunch. So it says convert from polar. Notice it's polar because there's an r and then a theta. So theta is in degrees here. It can be in degrees or radians. Doesn't matter. So we have 4, 150. We're going to convert it to rectangular coordinates instead. So we're going to have to use this knowledge. Now we're trying to take this. This is an r. It kind of helps me sometimes because these get confusing for me. Saying, okay, this is r theta. I'm trying to get it to be x, y. So then I know I'm going to be using these two things. Does that make sense? So we know that x is equal to r, which is 4 cosine of theta. Theta is 150 degrees. And our y value will be 4 sine of 150 degrees. So now you'll go to your unit circle, locate 150 degrees so that we can actually simplify this to be actual distance. So what is cosine at 150? Well, negative 3, negative root 3 over 2. Very good.
I'm confused how you wrote it.
We use this formula. See how we have an r, cosine theta? We have r, we have theta. So do you see how we can just literally plug it in? 4 cosine of 150. Does that make sense?
Yep.
And then 4 sine of 150. But now you got to simplify it because we know the cosine of 150 is negative root 3 over 2. So we have negative 4 times root 3 over 2. No. We're now simplifying cosine at 150 degrees. So now isn't that negative 2 root 3? So our negative 2 root 3. So our x coordinate was negative 2 root 3. Now our y coordinate we're going to simplify because we can find the sine at 150. Sine at 150 is 1 half. Because go to your unit circle to 150 and then cosine is negative. Does that make sense? Okay, so this is 4 times 1 half, which is 2. So our y coordinate's 2. Now we have an xy point versus an r and a theta. That would put us in the same spot. It's just getting there differently. Now that's just a number, right? If we were going to plot that point, we would actually type out negative 2 times root 3, which is approximately, just making sure you guys remember, negative 3.46. Like, isn't it easier to graph that point than 2 root 3? You can't really conceptualize what that is. Divided, I mean, that's what we'd be plotting. That's a negative. So I just didn't. Does everybody understand? Question? Okay, we're going to call that good till after lunch. Okay. So r squared, you'd say, I need it to be in terms of x and y if we're going from polar to rectangular. So isn't that the same thing as x squared plus y squared? Yeah. So this as a rectangle would be, a rectangular coordinates would be x squared plus y squared equals 4. So then isn't it true to say that's a circle with a radius equal to 2? Isn't that a circle equation? And a radius of 2. So we converted. Questions on that? Pretty straightforward. Okay, next problem, write it down, because this one's a good one.
This one's hard.
No, this one's actually easier than it looks. It's just recognizing it. Convert from rectangular to polar. So now we're going backwards. We have in terms of x and y, we need it to be in terms of r and theta. So you would say, what's x squared plus y squared the same thing as? R squared. So rewrite that as r squared to make it polar. And over here we have 9 times, what's y divided by x? Tangent. Now it's in terms of theta squared, right?
Yeah.
So now we always want it to be r equals the equation, not r squared. So the next step to get r alone would be square root, both sides of the equation. So r is equal to, root cancels out with power, the square root of 9 times the square root of tangent theta squared. I'm just showing my work here. So r is equal to 3 tangent of theta. Root cancels out with power. Now we have it in terms of r and theta instead of x and y. Good point. Now, actually, that presents us a good point. We could put plus and minus 3 if we wanted, and we're going to talk about what the negative radius means in a minute. So you could put it, it wouldn't be considered wrong, but with polar coordinates, it's not necessary. We'll talk about what a negative radius means, but it wouldn't be wrong either. Because think about what a negative, I'll tell you. So a positive radius goes up like that, you know? And then a negative radius would be down like this. So do you see how like one radius takes care of all radiuses?
Yeah.
That's actually a good point. We'll get more into that in a second. Yes. No, we square rooted both sides of the equation, right? So then square root of 9 is 3. Square root of anything squared, the root cancels out with power. Tangent squared, square root of tangent squared is just tangent, right? Just like square root of x squared is just x. No, because it was just look right here. See how it was just tangent squared? Does that make sense? Good questions. Really good questions. Okay, next one. Write it down. What? We don't have to write it. It would be fine if we did. And we'll talk about the negative radius in better detail in a minute. It just, because instead of having it in x and y, we now have it in r and theta. What don't you get? Like, I'm confused. We're not necessarily graphing it. It just said convert it from rectangular, this is an equation. So we're taking I should have been more specific. And for instance, this is a rectangular equation, and now we have a polar equation. So it wasn't a point, it's my fault. Yeah, rectangulars when you have x and y, and then polars when you have r and theta. So it says convert the rectangular to polar. So we have x and y, we want it in r and theta. So you've got to look at it and say, how can I manipulate it? Well, isn't y, remember our little basket of goodies that we can use? So we have 3, and then instead of y, we want it theta. So we'll have 3 times r sine theta, and then minus 7 times, yeah, sorry, I just had to make sure I wasn't thinking wrong. R cosine theta equals 10. Now you'd say to yourself, I want it to be r equals just because that's nice and pretty, so what can I factor out? I forgot to write an r, right, didn't I? Good, factor out an r, so then divide by r. So then that would be 3 sine theta, because look, your r's divide out, 3 sine theta, minus our r's divide out, 7 cosine theta equals 10. Now solve for r. So we'll divide by that, divide by that. I didn't want to rewrite that. So I will in my final answer. R is equal to, when I say that, I mean that. Divide by that. Okay, so, oh my gosh. 10 over 3 sine theta minus 7 cosine theta. So now we have an equation where it's r and theta.
And that's a good answer.
Yeah. Yeah. No, there's not anything we can do to simplify it. 3 we go. Let's convert to polar. Same type of deal, right? Do you guys want to just try it by yourselves?
Sure.
Okay. Yes.
Equal to negative 3 over sine theta minus 2.
Good. Very good.
Thank you.
What?
Thank you.
So y is what?
Yeah, r sine theta.
So r sine theta equals 2 times r cosine theta minus 3. Is there questions on that part? Yeah? Well, we have these basket of goodies.
Oh, wait, no.
Oh, okay. Okay. So now from here, you're trying to get it r equals. We have 2 r's. So wouldn't we subtract, bring all the r's on one side of the equation and everything else on the other side? So we subtract 2r cosine theta, subtract 2r cosine theta. So that leaves me with r sine theta minus 2r cosine theta equals negative 3. Now we're trying to get r alone, so can't we factor out an r at that point? We factor out an r, then left would be sine theta minus 2 cosine theta equals negative 3. And then you're trying to solve for r. So then you would divide by that, and we end up at the solution. But it's just plugging in, and then getting all the r's on one side and everything else on the other side. Okay, so now we're going to talk about how negative r works, because this is different than you might think. So remember how we talked about how if you're standing here and you are blindfolded and I tell you to go, for example, pi force and then out 5 units. Everybody, for example, even though it just says r, let's say I said go pi force and then out 5 units. This would be you and you'd walk out here, correct? There you are. Now, doing a negative radius, you would still say up pi force, but then negative 5 would just then be walking backwards. And then you've arrived. So that would be putting you like this. So that's how a negative radius works. That's still considered pi force though, guys. Just negative r distance. Does that make sense?
Yeah.
So we still went up pi force, but then negative r. So this would be negative r pi force, which feels weird because pi force isn't down here. Does that make sense? That's just how polar coordinates work. Questions? Okay. So let's do, now think about this one more time, one more thing. If we were around 2 pi and out 2 units, isn't that the same thing as around 4 pi and out 2 units? Wouldn't that put me at that same point?
Yeah.
Okay, just keep that in mind. Yep, as same as 0 pi. Good. So we can do that as many times as we want. Okay, so here, write this one down, because this one confuses people. So it says plot 3 negative 3 pi force on an interval from negative 2 pi to 2 pi. And find 3 additional polar representations, meaning you've got to end up in the same spot at that same point. So it's kind of nice with this one to have a visual of what we're looking at. So let's draw in what this actually is, what this looks like. So negative 3 pi force. Now picture where here's positive 3 pi force. So that was up that many units. So negative 3 pi force would be down here, right? So we would draw in down here. I'm going to change colors real quick. Right down here would be going negative, that point, negative 3 pi force. And now we're going to go out 3 units. So out 1, 2, 3 tick marks. Oh, so my point would actually be right here, because of how I drew my picture. This is the arrow continuing. There's my point. Does everybody see?
Yep.
We went negative 3 pi force, and then out 3 units.
Yeah,
Does everybody understand? Now these circle, right, like not to confuse, but remember these are like the circle continues like this, right? It's our third. Okay, so now an additional point would be going at, can anyone think of how we could get back to that green point? Add 2 pi, yes. So we could be add 2 pi, or you could subtract 2 pi, right? There's multiple right answers. Wouldn't that put me back at that theta? Remember, we have to graph theta first. So going around 2 pi, that's a good idea. So, and out 3 units. So going out around an additional 2 pi, and then out 3 units would put us there. So 3 comma, and then negative 3 pi force, and we're going to add 2 pi. So putting us in the same spot would be 3 and 5 pi fourths. So going, now why does that make sense? 5 pi fourths and then out 3 units. Look, going around 5 pi fourths and then out 3 units puts us in the right spot, doesn't it? Right here's 5 pi fourths, 3 pi fourths. Does that make sense? Okay, so another one is you've got to do a negative radius, you've got to work backwards. So you have to be standing like this. So that would be creating this, going up this amount, and then back 3 units to get us there. So what would that measure that angle be? Pi fourths, guys. Isn't that straight down? Look, pi fourths is straight down from 5 pi fourths. So you would go up pi fourths and then negative 3 units. So you have to write it as negative 3 and pi fourths. Because we need to get back here, and it's walking backwards. So we had to go, to get back to that star, we had to go up positive pi fourths and then walk backwards 3 units. No, here's what, then these are really our only options because of the interval. So we could only add 2 pi one time. Does that make sense? We couldn't do it again because of the interval. It allowed us. Does that make sense? Yeah. So what's another one? We have to go here, right? We have to be here to go backwards. So isn't that also negative 7 pi fourths? Negative 7 pi fourths. Going backwards instead of up pi fourths, going this way. Does that make sense? Yep. So negative 3, negative 7 pi fourths. Because look, here's positive 7 pi fourths, guys. So if we went negative 7 pi fourths, that would be ending us right here. Does that make sense? Then we have to walk back 3 units to get us to the right spot. So these were the 3 answers. Negative 7 pi fourths, 5 pi fourths, and negative 3 pi fourths. Yes. Let's see. Well, here's what you have to do. You have to draw the angle first. So it could be, so if I drew this angle and then said walk negative, that'd put me here. Does that make sense? But if I went out here and then said positive, that'd put you out here. So it just depends. It could be anywhere. Yeah. Okay, so here we go. Convert to rectangular points. So now notice instead of an equation, we're given a point. And instead of graphing that point, which we know where that's going to be, think about where that'd be. Going pi, right? And then out 2 units. Ding, ding. Wouldn't that be there? Okay, so now it says convert it to rectangular. It's going to be at that same point, but it's rectangular. So you're going to use your little basket of goodies once again. So this is an r theta. We want it to be xy. So you'll have to remember that x is equal to r cosine theta, and y is equal to r sine theta. So let's plug it in. R is 2, so we'd have 2 cosine of pi, and then r is 2, so we would have 2 sine of pi. So 2 times cosine at pi. The cosine at pi is, what's this point? So that's 2 times negative 1, which is negative 2. So our x value was negative 2, which makes sense. Look, guys, negative 2 tick marks would get me there. And then if you do 2 times sine of pi, which is 2 times 0 equals 0. So negative 2, 0 does put me in the right spot, so I know I've done it right. 2 times sine of pi, that's all we did. Because we used the r sine of theta is y. Because that's what y is, right? In polar. So then 2 is our r. And then theta is pi, right? Look, r theta, so just plug it in. 2 times sine at pi. Sine at pi is 0. 2 times 0 is 0. So we got 0. Okay, let's do B. So converting this, so here we go. So this one's polar. We're converting it to rectangle. So you'd say x is equal to r, which is root 3, and then cosine at pi 6, r theta. And then y is equal to root 3 sine at pi 6. So go to pi 6 on your unit circle, and you know that that is root 3 over 2. Cosine is root 3 over 2. So we have x is equal to root 3, and then cosine at pi 6 was root 3 over 2. Isn't that root 9 over 2? Which is 3/2. So our x point now is 3/2. It's rectangular now, 1.5. And then our sine is, you'll do root 3 times the sine at pi 6, which is 1/2, which equals root 3 over 2. So our y value is root 3 over 2. Now, obviously, if we were going to plot that point, we'd actually calculate root 3 over 2 because that's a decimal. You know what I mean? It's easier to plot points as a decimal. Does everybody see what I'm doing? Okay. Almost done with our examples here. Convert to polar. Notice they're rectangular coordinates convert to polar. So right here we're given an xy point, and we want it to be r comma theta. So I would like you to remember that r stands for radius. So we are going to draw a picture here. So this is negative 1 up 1. So we're dealing with that point, negative 1 up 1. So to find the radius of our circle, we do Pythagorean theorem. 1 squared plus negative 1 squared equals r squared, right? Pythagorean theorem. So then that's 1 plus 1 equals r squared. So 2 equals r squared. So our radius equals 2. So r is 2. No, it's not. It's root 2, isn't it? Okay, so we have root 2. Now, we also know that tangent of theta is our y value divided by our x value. So we'd say tangent of theta equals our y value, which is 1, divided by negative 1. When does tangent of theta equal negative 1? Three pi fourths. That actually happens in 2 places, but we need to end up here, right? So we need to put this one right here. So does everybody understand that that'd be 3 pi fourths? Okay, so our answer is square root 2 and then 3 pi fourths. That would be putting us in that same point, but to me it's easier to graph negative 1, 1 than that, but just saying. We solved this just like in the last test. When does tangent of theta equal negative 1? So look at your unit circle. Tangent means y divided by x. So does that make sense? Negative root 2 over 2 divided by root 2 over 2 is negative 1. So it happened at 3 pi fourths. Yeah, because that was one of our, the bag of tricks that we've been using. This bag of tricks. That was one of the ones that we were doing. Yeah. Okay, let's keep going. B. Okay, here we go. So it says convert it from linear xy point to polar, which is radius comma theta. So once again, this is over 0 up 2. Okay, up 2. So what's the radius of my circle going to be? 2. So we know that our radius is 2. Then what's our theta going to be? We don't have a triangle, so we're going to have to just think about it. How can I tell you to get to that point? By using the radian. 90 degrees, very good. And we'll just write it as a radian just because we like it. Pi halves. Me too. Okay. Let's see. So you could graph 3 pi halves and then go negative 2 units. That's also a possibility. So you said 3 pi halves, not negative. Sorry, 3 pi halves. Yep, it just means put it in the same spot. Yep, that would work, but then it would have to be negative. Good. That would put me also in the same spot. That's good. That was good. Okay, it says describe the graph and convert to rect. This is literally the last example. Then I'll give you the homework. And we might not even need to do it. No? doing all or nothing, so.
Nothing.
What would this be then? Describe the graph. It would be in rectangular, describe the graph. That's what I want you to do. In rectangular coordinates, what would the graph be? Nope. Has a radius of 2. So it'll be every point that falls on the radius, circle with radius 2. Circle with radius equal to 2. So it would be any point that falls on right there. Does everybody understand? No, you weren't. What? Okay, so right here it says, describe the graph. So everybody, this would be a circle. This would be going up pi thirds, right?
Yeah.
Going up pi thirds, and then any point that falls on that. So what would be the rectangular equation that would work there? Well, so it is supposed to be. I'm sorry. It's not the circle. It's every point that falls on the line of pi thirds. Sorry. So that's this, right? What I meant to do is, sorry, my fault completely. Like this, right? Sorry, my bad. Yep, good. Yep. Any radius, but it will always be at pi thirds. Any radius. Okay, so then the equation for that would be, you'd say, okay, well, tangent of theta equals y over x. So to get it in rectangular, you'd say tangent at pi thirds equals y over x. What is the tangent at pi thirds? So look, pi thirds, tangent that divided by that, which is root 3, everybody. So we'd say root 3 equals y over x. So then y is equal to, we multiply both sides by x. X root 3. That would be the linear equation for that line, like Sarah said. Okay, so with this one, that's the same thing as r is equal to 1 over cosine of theta, correct?
Yeah.
So now we multiply both sides by cosine of theta. So we have cosine of theta r equals 1. Well, isn't r cosine theta equal to x? So that becomes x. So x equals 1. So you'd say any point on the line 1. Okay, here's your problem. That's 18 problems. 18 problems.